Welcome. Today we take the first chapter of coordinate geometry, and name of the chapter is coordinate system and straight line together in 2D. Today is first part of that. So first of all, let us discuss few results. In any triangle, it has four type of center. Number one, circumcenter, centroid, and orthocenter. I think you know it. Orthocenter, actually it is a point where the perpendiculars drawn from vertex to the opposite sides, they meet, orthocenter. Then centroid. Centroid is the point where medians meet, and circumcenter is a point where the center of the circle, which the circle means the circle which passes through the three vertices. This is circumcircle. Its center is the circumcenter. So there is a very important rule. The orthocenter O, centroid G, and circumcenter C, they are collinear. For any triangle ABC, its orthocenter, centroid G, and circumcenter C, they are collinear. And if it is O, this is G, and this is C, then G divides OC internally in the ratio 2:1. It is very, very important formula for any competitive examination, because knowing any two tactfully to find the other, in that time you have to use this relation. Next information is that for a right angle triangle, the vertex containing the right angle is orthocenter of the circle. Then suppose this is a right angle triangle ABC. B is the vertex B is 90 degree. So for that triangle ABC, B is the orthocenter, because from the vertex A on BC, opposite side BC, this is our perpendicular. From C, perpendicular on AB is CB, so they meet at B, and from B to the opposite vertex of opposite side AC, so is this. So these three perpendiculars meet at the point B. So remember it clearly that for any right angle triangle, the vertex containing right angle is the orthocenter of the triangle. And for a right angle triangle, this is hypotenuse, its midpoint will be the CG, will be the centroid, circumcenter, and orthocenter is this, centroid, circumcenter. Circumcenter will be the midpoint of the hypotenuse if the triangle is right angle, and this is the midpoint of the hypotenuse. Okay, next information, it, I think you know it. For 2 points r1 theta 1 and r2 theta 2, 2 points in polar coordinate, the distance between the 2 points is root over of r1 square plus r2 square minus 2 r1 r2 cos of theta 2 minus theta 1 or theta 1 minus theta 2, same thing. Area of the triangle whose vertices are r1 theta 1, r2 theta 2 and r3 theta 3 is half. Area of the triangle is equal to half mod of r2 r3 sine of theta 2 minus theta 3 plus r3 r1 sine of theta 2 theta 3 minus theta 1 plus r1 r2 sine of theta 1 minus theta 2 square unit. The translation of axis without rotation. Let us see what is that. Suppose this is a axis system. O is origin, x-axis, y-axis. Any point P is, say, xy. Now these axes are shifted to that point, say. That point is, say, A point, whose coordinate is hk. With respect to this system of coordinate system, it is hk. Origin is now shifted to here, and axes are parallel to the previous one. This is parallel to that, this is parallel to that. Now, with a new and old system of coordinate system, old system P xy is the coordinate of a point, and same point with respect to that system is capital X, capital Y, then x is equal to capital X plus h, y, small y is equal to capital Y plus k. Old system, this is new system, and h and k where the origin is shifted. So from this, from old system to new system, or from new system to old system, we can go. So next, a straight line, equation of straight lines I am not discussing. One particular equation, suppose a straight line passes through x1, y1, and it makes an angle theta with x-axis. Then its equation can be written as x minus x1 by cos theta is equal to y minus y1 by sin theta, and let it be equal to r. This is equation of straight line passing through x1, y1, making an angle theta with x-axis. Then its equation is this. Let us take it as r. Then any point on that straight line is x1 plus r cos theta, and x is equal to comparing this and that, r cos theta plus x, comma, y is equal to y1 plus r sin theta. For different values of r, we get different points. So r, what is r? R is the distance of a point. R is the distance of a particular point from this x1 and y1. This formula also very important for calculating a point at a particular distance from a given point. One more result. Suppose a1x plus b1y plus c1 is equal to 0 is a straight line, and another straight line is a2x plus a2x plus b2y plus c2z is equal to 0. These are two straight lines. Now, the general equation of a straight line passing through this and that, passing through meeting point of this and that is equal to 0. For different values of k, different equations can be obtained through the meeting point of the two straight lines. K can be obtained, value of k can be obtained from another given information. Now, next one is, say, aix plus biyi plus ci is equal to 0 for I is equal to 1, 2, and 3. That is, there are three different straight lines. They will be concurrent, means these three straight lines will pass through a particular point, one particular point, provided this one, this value of this determinant a1, b1, c1 from the first straight line. Second line, second row a2, b2, c2. Third row a3, b3, c3. If that determinant is 0, then we can say that they are concurrent. These straight lines are concurrent, means passes through a particular point. So next, one more. Suppose a1x plus b1y plus c1 is equal to 0, one straight line, and another straight line is a2x plus b2y plus c2 is equal to 0, second straight line. Then one straight line, second straight line. Then actually these two straight lines make two angles. One is this and other is that. Equation of their bisectors means equation of this bisector of this angle is this, and equation of bisector of this second angle is this. Number one, they are these two straight lines, these two bisectors, they are straight lines, they make an angle 90 degree always, number one. And number two is equation of bisector of the angle containing origin. Means, suppose this is the axis system. O is this x-axis, y-axis. So this angle contains origin, this angle. Bisector of this angle is equal to, oh sorry, before that, before discussing that, let us take these two equation of bisectors are number one, a1x plus b1y plus c1 divided by root over of a1 square plus b1 square is equal to plus minus second equation b2y plus c2 by root over of a2 square plus b2 square. Corresponding to plus, we get one equation of bisector. Corresponding to negative sign minus, we get another equation of bisector. So we get two equation of bisector. Which one is equation of bisector containing origin, or which one is equation of bisector of acute angle? Not yet defined. Now I define the, suppose this angle contains origin. Its equation of bisector will be, that means this, it will be, we have to choose this sign plus or minus so that constant sign of constant terms from both sides become same. If it is positive, it is negative, we have to choose negative sign. Then that will give you the equation of bisector, which bisector of the angle which contains origin. And for acute angle, equation of bisector of acute angle, for that purpose we have to simplify one equation of bisector, say plus, corresponding to plus. From there we can find its gradient m1 and take any one of the given lines, say this, find its gradient. Very easily it is minus a1 by b1. So it is m2 say. Now check whether angle between this and corresponding to plus sign, theta say, it is equal to tan of, I mean tan theta 1 m1 minus m2 by 1 plus m1 m2. If this value, magnitude of this value is less than 1, then less than 1 means this angle is less than 45 degree. So whole angle is less than 90 degree. So this is acute angle. So in that case, this one will be the this one will be the bisector of the acute angle. Okay. So if it is not less than 1, then other one, that is then corresponding to minus sign, that will be the equation of bisector of acute angle. These two are very important for competitive exams. Okay. Now let us take few problems today. First problem. The vertices of base of an isosceles triangle are at A 2p, 0 and B 0, p. If third vertex lies on the line x is equal to 2p, then area of the triangle is options 5p square by 2, 7p square by 2, 3p square by 2 and 5p square. In that case, the given informations are One triangle is given, isosceles triangle. Two of its vertices are this and that. And just 1 minute. And it is base of the base of the isosceles triangle, this and that. And other side lies on that straight line. Then area of the triangle. First draw it 2p0. This is 2p0 say, and this is p0. Zero p, and third vertex lies on that. This is a straight line. X is equal to 2p, means it passes through the point 2p comma 0, and it is parallel to y-axis. So it is like that. X is equal to 2p. Third vertex is somewhere there on that, and it is a isosceles triangle. Suppose, and it is base. Therefore, suppose this is the triangle. It is A, this is B, and this is C. Suppose, as because third vertex lies on that straight line, third vertex will be x coordinate must be 2p, and y coordinate say k, unknown. We have to find it out. It can be found from the information that BC is equal to length BC is equal to length AC, isosceles triangle. BC square is equal to AC square. BC square is equal to 2p minus 0 whole square, that is 4p square, plus k minus p whole square is equal to AC square. 2p minus 2p 0, it is simply k square. So that 4p square plus k square minus 2kp plus p square is equal to k square. K square cancels. So k is equal to that k, it is equal to 5p square by 2p is equal to 5p by 2. 1p cancels. So third vertex is actually 2p, 5p by 2. Now we get all the three vertices of a triangle. To find its area, there are so many methods. Vertices are there, so area of the triangle can be obtained. But in this case, draw perpendicular from this to that. This straight line is parallel to y-axis. Perpendicular is drawn, so it is parallel to x-axis. So it is parallel to x-axis. Suppose this point is D. So area of the triangle ABC is equal to half into AC into BD is equal to half into AC. How much? A to C. This is lies on the line. X is equal to 2p. So this length is k, simply k, because it is 2p0, this is 2pk. Distance is k minus 0 whole square root over. And this is k into BD. BD from this to that. That is, it is actually the x coordinate of the point C. X coordinate of the point C, because this is equal to that, is equal to x coordinate of that or x coordinate of that. So another 2p. So it is equal to half. K means 5p by 2 into 2p. So that 2 cancels, 5p square by 2 square units. So it is 5p square by 2 square units. First option is correct. Next problem. The number of integral values of m for which x coordinate of the point of intersection of 3x plus 4y is equal to 9 and y is equal to mx plus 1 are also integers. So this problem is given in West Bengal Joint Entrance in the year 12. So once again I am repeating the problem. The number of integral values of m for which x coordinate of point of intersection of these two straight lines are also integer. This is a straight line, this is a straight line. Solving them, we get 1 point. 1x, 1y. We have to find how many such values of m which are integer so that point of intersection are also integer. Solving this and that, we get 3x plus 4 into y means that mx plus 1 is equal to 9. That is 3x plus 4mx is equal to 5. 9 minus 4. So that x is equal to 5 by 3 plus 4m. As a main problem, I'm reading it. The number of integral values of m, for which x coordinate of point of intersection of this and that is this, are integer. This is integer, m must be integer. M and x both are integers. Now on trial, you see, if it is 5 or 1, if denominator is 5 or minus 5, or if it is 1 and minus 1, then only x will be integer. It is 5 and this, if this is 5, so 1 integer. If this is minus 5, x is minus 1 and integer. If it is 1, this is 5 and integer, minus 1 also integer. Now we see, if this value is 5, what happens? 3 plus 4m is equal to 5. So m is equal to 2 by 4, not an integer. Now take it is minus 5. 3 plus 4m is equal to minus 5. Then 4m, rather m, is equal to minus 8 by 4, minus 2. It is an integer. So m is equal to minus 2, x coordinate is an integer. So 1 is correct, number 1. Now take 1. This value take 1. Then 3 plus 4m is equal to 1. 4m is equal to minus 2. M is equal to minus half. So it is minus half. It is not an integer. Next take last one, that is 3 plus 4m is equal to minus 1. So 4m is equal to minus 4. M is equal to minus 1, an integer. So for minus 1, it is m is an integer. For this is minus 5, another integer. So the result is 2. Options were not given. The options are given as 0, 1, 2, and 4. So this option is correct. Next. Next problem is area of the triangle whose vertices are 1, 5 pi by 6, 2, pi by 2, and 3, pi by 6. These three vertices of a triangle are given. We have to find its area. Obviously, they are given in terms of polar coordinates. R1 is 1 and theta 1 is this, and so on. We know that the area is half into modulus of R2 R3 sine of theta 2 minus theta 3 plus R3 R1 sine of theta 1 minus theta 3 plus R1 R2 sine of theta 3 minus theta 1. No, it is theta 3, theta 1 minus theta 3, and this is theta 4, theta 2 minus theta 3, theta 3 minus theta 1, theta 2 minus theta 3, theta 1 minus theta 1 minus theta 3, and here is theta 3 minus theta 2. Just there. Oh, it is difference of angles. It is actually from this minus that. So it is this minus that. So it is equal to theta 1, theta 3. Then it is equal to this minus that. So it is equal to theta 1 minus theta 2. Now I think all right. Mod. It is equal to, and square unit, half of, this is R1, R2, R3. So that it is R2 into R3, that is 2 into 3 into sine of theta 2 minus theta 3, theta 2 minus theta 3, pi by 2 minus pi by 6. So it is pi by 3. Pi by 2, 90 degree minus 30 degree, plus R3 R1. R3 means 3 into 1 into sine of theta 3 minus theta 1, pi by 6 minus 5 pi by 6, plus R1 R2. R1 R2 is 1 into 2, sine of theta 1, 5 pi by 6 minus 5 pi by 6 minus theta 2 is pi by 2 mod. So it is equal to half of. Now I think you can simplify it. 6 into sine of 60 degree plus 3 into, this is 5 pi by 6 minus 6 with negative sign, then it is 4 pi by 6. 5 pi by 6 minus pi by 6, 4 pi by 6, 2 pi by 3. So it becomes negative sine of 2 pi by 3 plus 2 into sine of 5 pi by 6 minus pi by 2. So it is equal to 30, 150 minus 90. So sine of 150 minus, so 60 degree, pi by 6. Now put the values, all these values, this and that, and result actually is 5 root 3 by 4 square units. Now next problem. The coordinate of 2 points on x plus y is equal to 4 at an unit distance from the straight line 4x plus, just 1 minute, 4x plus 3y is equal to 10 are, options are minus 3, 7, 7 minus 3, number 1. Number 2, 5 comma minus 1 and minus 1 comma 5 and 3 comma 1 and minus 7 comma 11 and 3 comma 1 and minus 7, oh, 3 comma 1 and 4 minus 5 comma 9. It is given actually, it was a problem given in West Bengal Joint Entrance Board JEE in the year 2011. The problem is that we have to find 2 points on that straight line from where distance from this point to that straight line is 1 unit, means 1. It is like that. Say x plus y is equal to 4 is that straight line. X plus y is equal to 4. And it is of the type, say, suppose this is this one. 4x plus 3y is equal to 10. From this point, distance is 1. From that point, distance is 1. So we have to find from this point, perpendicular distance is 1. So we have to point, say, A point and B is another point. From there, distance on this straight line is 1 unit. For that purpose, the very easiest way is that you can take a point on that straight line, and preferably parametric point. Suppose you take the point A, this point is A, say A, x coordinate is A, y coordinate will be 4 minus A. This is called parametric coordinate. So because with the help of only one unknown quantity A, we get a point. This will simplify, this will be very simple calculation. Now, problem is from this point, perpendicular distance from this point to that straight line will be 1. So we get 4A from this point to that straight line, 4A plus 3 into y. Y coordinate is 4 minus a is equal this by root over of 4 square plus 3 square is equal to 1. And perpendicular distance is 1. If from this point to that, this direction, distance is 1, then from this to that, this distance will be minus 1. So it can be taken as plus minus 1. So we get 4a minus 3a, that is a plus 12 is equal to plus minus 5 into 1. Taking plus sign, a is equal to minus 5 minus 12, that is minus 7. And taking minus sign, a is equal to minus 17. Oh, 3a, 4a plus 3 into 4 minus a is equal to 10. This is minus 10. আচ্ছা, okay. ঠিক আছে. Take this is minus 10, get a, and we will get 2a, one for plus sign and one for minus sign, and this will be the correct options. So next day we'll discuss problems on next day.